Hello everybody, in this video we'll try to learn or understand the end behavior of a polynomial function. Just to remind you, in the last video we saw the end behavior of a polynomial function using a power function of x equals a x power n, and we have seen that we have four cases. Case 1, if a greater than 1 and n equal to even, and the example is function of x equal to x square, and this is a simple parabola. And if a is less than 1, there's the parabola opens down, and so on and so forth. So I just want you to see these four different cases and see the four different shapes. So in this video we'll try to understand not only a power function, rather for a polynomial function. So let us use an example equation. So let's say I have function of x equals 2x cube plus 5x square minus 7x plus 11. Okay, so this is my polynomial function. So what we need to show that the end behavior of this particular polynomial. So end behavior of this polynomial is like end means what? End behavior means if x is a large number, or a high number, like for example x equal to 100, x equal to 200, 150, x equal to -100, -150, something like that. Okay, show that if x is large, then the function behaves or simply like the first term or the leading term, that function of x almost equal to 2x cube when x is very large. So that means we need to show that the end behavior, that means when x is large, then my function behave like this power function. Okay, so let us try to prove. So first of all, what I'm going to do is I'm going to rewrite this function into, so let's see, 2x cube is x cube, so I have no problem here. Now let us see, I have 5x square. Okay, so what I'm going to do is I'm going to write down 5 over x multiplied by x cube. So this is actually same as 5x square. I hope you understand. Then negative 7 over x square multiplied by x cube, this is going to give me negative 7x, and plus 11 over x cube multiplied by x cube is going to give me positive 11. Okay, now what I am going to do is I am going to take x cube from all this term, as you can see, out of my outside. Okay, so if I write, or if I take x cube outside, so what I am getting is, for the first term I am getting 2, for the second term I am getting 5 over x, for the third term I am left with negative 7 over x square, for the fourth term I am getting positive 11 over x cube, and that's it. Okay, so this is basically my function of x. All right, so now let us see what is individually what is going to happen with each of my this term when x is large. So let's take let's say if x is large, let's say if x equal to, let's take an example like let's say x equal to even let's say 10, or I can say take 100, but I don't want to take such a big number. I want to take even a little small number. So if x equal to 10, let's see what happened with my this term 5 over x. So 5 over x, which is what equal to x is 10, so 5 over 10. So 5 over 10 is what, 0.5. okay, fine. And let us see what is happening with 7 over x square. So 7 over x square is what, 7 over x is 10, so 10 square, which is what, 7 over 100, which is what, equal to 0.07. Similarly, let us see what is happening with 11 over x cube, which is basically equal to 0.0011. all right, so that's what so now as you can see these number, as you can see these numbers are what, very small or almost zero. So what can I say, that these numbers are almost equal to zero, this is almost equal to zero, this is also almost equal to zero. So what I am left with, guys, I am left with x cube 2 plus 0 minus 0 plus 0. So I am left with 2x cube, which is function of x. So instead of writing equal sign, I should write almost equal to so I can write that this is almost equal to rather than a equal sign. So what I found, that my function of x is going to behave or equal to 2x cube if x is large. That means what, my behavior of this particular function, which is a polynomial function, a big function, as you can see 2x cube plus 5x square minus 7x plus 11, that function is going to behave, or the end behavior, or when x is large, it is going to behave like this power function. Okay, now let me try to plot it. So what I'm going to do, I'm going to, let's say, zoom out a little bit, and let us try to plot this. Okay, try to see what is happening. So this is my x and y axis. I want to remind you what is the behavior of 2x cube, guys. If you look at my previous video, you are going to see what is the behavior of function of x equal to x cube. This is the behavior. Okay, so now let us try to see. So at least when my, let's say x is 1 here, 2 3 5, so when x is large, so in general let's say this is my x equal to 10, so it is going to behave like how, of course in the mid portion, sorry, in the initial portion, so this is the this is basically the plot of what, 2x cube. Okay, now when what, x is large, that means when x is like, let's say here x is 10, here x is 100 something, or like let's say here x is negative 10, here x is negative 30. So this is the behavior, okay? This is the end portion of the behavior is, so this is the end portion of the behavior is what? Similar to my this 2x cube, okay? Now what about this behavior of the middle portion? Like behavior of the middle portion is going to be determined by all these other term like 5x square, all this other term like 5x square, negative 7x plus 11. So of course we do not know exactly until we solve this problem. So but what I am going to do is, for the middle portion I am going to just approximate, okay, approximate something like that, of course using a dotted line. Okay, so this is the approximation for the mid portion. Of course in the middle portion we need to do a more rigorous solution, but at least what we learned, that at least for the end portion is going to behave like the leading term. Okay, so the behavior end portion will be using this leading term. Okay, so now let us check the leading term test, and this time I'm going to use a generic polynomial equation. So let us see the generic polynomial equation. So the leading term test. So I just want to remind you what is the shape or general form of a polynomial function. An x power n plus a n minus 1 x power n minus 1 plus dot dot plus a 2 x square plus a1 x1 plus a naught. Okay, so this is the general form of any polynomial function. Okay, now as you know and saw that this is my leading term with the highest power, which is n in this case. So what is my leading term? So my leading term is equal to an xn. Okay, now we just saw a little while ago that we just saw a little while ago that my that end behavior of a polynomial, and behavior of a polynomial is what? Determined or by the leading term 2x cube in this case. So for my particular problem here, which is an xn, so my whole polynomial function, the n behavior will be controlled by this term an x power n. So end behavior will be controlled by this term, and behavior controlled by this term. Okay, now we are going to try to plot the end behavior of this polynomial function. Okay, this polynomial function using this leading term. Now before I do that, I just want to show you this four graph, and as you can see, these four graphs are what, based on this power function a x power n. As you can see, we have four different shape. So now this will be exactly same. There is no difference in this case, but in this case we are so again I am going to divide my graph, divide my page into four quadrant, and for the case 1, so for case 1 here I'm going to try to plot case 2, here I'm going to try to plot case 3, here I'm going to try to plot case 4. Okay, so now for the case 1, this is what, an is greater than 0 and n is what, n is even. Okay, so which is what, similar to just example, similar to what, y equals x square. Okay, this is a similar. Okay, so now if I let me use some other color. So this is my axis, y and x axis. Now of course the if I try to plot okay, so this is the actual parabola, but we know that the end behavior will be like that, but we do not know what will be in between when x is small number. So in this case, what I am going to do, I'm going to simply approximate, because at this point we do not know the exact equation. So it will be something like that. Okay, so this is the first one. Okay, first case. For the second case is what, an is less than 0 and n is still even, and this is what is the similar example, y equals negative x square. So the n behavior will be behaving like y equal negative x square. So let us try to draw my axes, and so this is the end behavior, and of course in the middle we do not know, we just approximate, or just approximating. All right, so this is for case 2. What about case 3? Case 3, an is greater than 0 but n is odd this time. An example will be, so the n behavior will be similar to y equals x cube. Okay, so let us try to plot and of course if you remember, so n behavior will be something like that, and what is going to be my behavior at the middle, it will be, we do not know at this stage without solving exactly. Okay, and let us see the fourth one, which is what, an is less than 0 and n is still odd, and so but n behavior will be basically similar to y equals negative x cube. And if I try to plot the behavior, so n behavior will be, on this side it is going to go up, and on this side it is going to go down, and in between it will be of course we need to solve it properly, but I'm just approximating. So now, so these are the end behavior for all 4 cases. Now if you compare this with our previous one, you can see here I have end behavior for a power function, means for the whole function, and this is the end behavior where only thing is we do not know the mid portion behavior or the middle portion, which we are going to learn subsequently. Okay, so this end behavior of the graph is very important. Okay, so in the next video we'll try to learn a real zero of a polynomial function. Okay, so